Hello friends, welcome to videos Learn New Technologies, video number 42. Today topic is laser cutting operation. Machine used, laser cutting machine. As you can see, this is the laser cutting machine which will be used for this operation. Now, the this is the same principle we are using to burn a paper with the help of lens using sunlight. Now, as the sunlight passes through this lens, it gets focused or concentrated to burn this paper. The same principle we are using with this laser cutting operation. Now, as you can see, the working principle of laser cutting machine. Now, in this case, we have the laser source. The laser beam would be generated from this laser source and it passes through the reflecting mirrors, right? And then it passes through the focusing lens. Now, after passing through this focusing lens, the focused laser beam is produced. Now, this beam, along with assist gas nozzle, would cut the sheet metal like this. Now, there is a curve width, cutting curve, which is basically this one width we are using for this cutting. Now, we have this slab table which can move like in X, Y, and Z axis. Now there are two things. One is a vaporized material and second is the ejection of melted material. Now the cut would be produced like this. So this operation is same as of this one, sunlight, lens, and paper burning process. So here this is, you can assume it to be a sun which is generating this laser source or sunlight. Then it passes through this focusing lens or reflecting mirror set. Then it passes to make the cut into this sheet metal, right? Then we have the machine category. The machine can be categorized into a laser source like the CO2, fiber, crystal, and diode. Now you can also take the reference of this sketch. This is the same sketch which is compare, as you can compare it with this example. Like we have this plane mirror. When it strikes over there, it goes to this focusing lens to produce the concentrated or focused beam. Then there's a gas inlet. Now this would cut the workpiece like this, right? So we have this laser source which is used for machine category. Like we have CO2 which is used for non-metal wood acrylic cutting. We have fiber which is for metal and high speed cutting. Then crystal for metal ceramics. Then diode for light duty crafting, right? So now we have laser cutting machine types and working principle. First of all, we have this CO2 laser cutting. What is the working principle? It uses a CO2 gas mixture to produce an infrared IR laser beam which is directed through mirrors to cutting head, right? So applications are for cut metals, plastic, and wood. This is a CO2 laser source, right? Second, we have fiber laser cutting. What is the working principle of this? It uses a fiber optic cable to generate and deliver a high intensity laser beam produced by a diode pumped fiber optic source. Now the applications for this is to cut metals like steel and aluminium, right? Then third is NDYAG laser cutting. Now what is the working principle for this? It uses a neodymium doped yttrium aluminium garnet like NDYAG crystal to produce a laser beam. Now the beam is directed through fiber optics or mirrors to the cutting head. The applications are for cut metals and ceramics. Now you can see, you can refer this working principle. Now there are three things. One is the laser source, one is the focusing lens, and third is the assisted gas nozzle, right? So basis on three things, we can define the types. Like CO2 here is the assisted gas in this case, right? So CO2 laser cutting is there. Then we have the fiber laser cutting. Here we are using a fiber optic cable to generate and deliver high intensity laser beam produced by a diode pumped fiber optic source. Now source in this case is diode pumped fiber optic source, and source in this case is through mirrors to the cutting head, right? It will produce a IR laser beam. So here we are using the mirrors and CO2 gas, and here we are using the diode pumped fiber optic source, right? And then we have ND-YAG laser cutting. In this case, what we are using? We are using a crystal, right? In this case, we are using the crystal to produce a laser beam. Then it is directed through fiber optics or mirrors to the cutting head, right? So these are CO2, fiber, and crystal laser cutting. Then we have this diode laser cutting machine working principle, which consists of the diode laser module. As you can see, it would produce the laser. Then we have optics and collimating lens, right, like this. Then we have this laser beam produced, and then we have the focusing lens. Then we have the fiber optics delivery system, just like a pipeline over there. So what we get? We get focused laser beam, high powered laser beam focused onto material. Second thing, heat and melting. Intense heat melts and vaporizes the material. Then we have the assisted gas. Assist gas blows away molten material, right? So what does this assist gas do? Assist gas blows away molten material. Then we have the cutting area, ejected molten material, right? So three things are there: laser diodes, fiber optics, and assist gas, right? Then these are the machine selection parameters. Now what are these things? These are 15 parameters. These parameters are just for reference. You can check the OEM or supplier, machine suppliers uh, technical specifications. These are just for the reference. In this case, first of all, you can consider the make. Then second is the enclosure. This could be open body, single pallet, or covered body pallet changer. Then we have the effective cutting range, like 6500 by 25, or these effective cutting range, or you can also assume to be a bed size, right? Then we have the watt, like 6 kilowatt. Then we have the laser source. There are such kind of laser sources over there in the market. You can check for anyone over there. Then we have the laser head, like this. Then we have the CNC systems, like this. We have the programming software, which is like SIPCUT, YHOM, RayTools, Godot Thinker, Alpha T2. So these programming software we are using to input the DXF data to the machine. Then we have the x-axis, y-axis, and z-axis coordinates, like this. We have the cutting thickness range in mm, like this. We have the positioning accuracy in mm, which is from plus minus 0.03 to 0.05. Then we have the power rating, like 3-phase, 380 volt, and 50 hertz. Then total power consumed, like this in kilowatt. So you can select the machine from these parameters, like, or if you want to purchase, then you can contact the suppliers as per these parameters, right? Then laser cutting operation in manufacturing. Now laser cutting is a precision manufacturing process where a focused laser beam is used to cut through materials. It's widely used for producing parts with high accuracy and clean edges. So as you can check before, we have already given you the description that how the laser cutting operation is being done, right? So you can check the standard operating procedure from here. First of all, prepare and secure the material on the cutting bed. Second, set the laser parameters like power, speed, focus. Third, upload the cutting design to machine's computer. Fourth, perform a test cut and inspect for accuracy. Fifth, initiate the laser cutting process. Sixth, inspect final parts and check for defects. And remember, always follow safety protocols and wear appropriate PPE kits, right? Then we have got the laser cutting defects, right? What are these? Now there are 9 defects which we have chosen for the reference only, right? First of all, poor cutting quality at only one side of the edge. Now what would be the causes for this? The cause would be like this. The cause would be laser beam is not aligned to lens, nozzle is blocked or not round, laser path not clean or not vertical to material. What are the solutions? Check beam centering, check nozzle, check laser head vertically or lens cleanliness, right? Then we have the wide, kerf too wide, like this. Now what are the causes? Gas pressure is too high, focus height is too high, too much laser power, poor quality of material, poor quality of material, right? So what are the solutions? Solutions are that reduce pressure by 0.1 bar every time, lower focus height by 0.2 mm every time, reduce laser power and clean material surface. Right, then third, burnt corners like this. The causes would be corner overheat. Then apply power curve or cooling point. Right. So fourth one, two rough serrations at cutting edge like this. We have the cutting edge, two rough serrations at the cutting edge. What are the causes? Gas pressure is too high, focus height is too high, cutting speed is too slow, or lens is dirty or damaged, right? Solutions are lower gas pressure, lower focus height, increase cutting speed, and check lens. And remember, when we are going to check this lens, always take care, right? Fifth one, soft legs that can be removed at lower surface like this. What are the causes? Cutting speed is too fast, focus height is too high, gas pressure is too high, right? What are the solutions? Lower cutting speed, lower focus height, and lower gas pressure, right? Sixth, coating peeled off at lower edge, like this. Causes would be gas pressure is too high, focus height is too low, cutting speed is too fast. Solutions are lower the gas pressure and cutting speed, increase focus height. Okay. Seventh, hard slags at lower surface of stainless steel sheets. What are the causes? Focus height is too high, gas pressure is too low, cutting height is improper. What is the solution? Lower focus height, increase gas pressure, adjust cutting height. Eighth, abnormal color of the edge. Causes would be N2 is not pure. Solutions change to pure N2. This is the case with the N2, right? Nitrogen, which is assisted gas in this case. Now, ninth one, abnormal defected starting cutting point. What would be the causes? Wrong setting of laser on-off delay or improper cutting lead. Now, from lead, as an operator, you can understand what is lead. This is just the starting point from which it would start cutting the hole like this, because it can start it from the this one periphery, so it has to start from inside of this like this. Okay, the what would be the solutions? Apply different lead line, reset the laser on off delay. Apart from these defects, there could be a dimensional defects and other defects also. So you can increase the number of defects as per your experience, right? Then we have some instructions for this laser cutting, like first of all, radiations are there, so always use goggles in this case, right? Second, always use the mask and keep fire safety or fire extinguisher along with machine. And most important, keep machine clean from inside on a daily basis, like do the 5S, try to do the 5S on a daily basis. Then I have given this reference format for uh, rejection rework trend. Like we have the operation, which is basically a laser cutting, or you can also make this sheet for the other operations like VMC, HMC, or plasma cutting, or any other welding operations like this to check the rejection rework trends, right? First of all, in this case we have the serial number like production quantity, how much production you are producing per day in a month and year. And then what with the okay quantity we are getting. Now after getting this 100 minus 95, it means 5 quantities are not okay. Now from this 5 quantity we have something which goes to rework and something which goes to rejection, right? So you have to choose the rework and rejection trend from these defects, right? And remember, this sheet is very important for doing the PFMEA, right? From this PFMEA, we are getting the PFMEA details from this sheet also, like what are the defects we are getting for the process. Okay, so for example, for 100 minus 95, there are 5 not okay quantities. So 2 quantities I am getting for a rework and 3 quantities I am getting for the rejection. So that's how I can calculate what is my rework percentage and what is my rejection percentage. I can check how many defects I am getting from this. Like if hearts legs I am getting from the 5 parts out of 100, it means it is too much quantity, so I have to check, I have to take the action for this, right? So this sheet is just for your reference. You can modify it as per your requirement and experience, right? And thanks for watching my video. Thank you.